All right, everybody, hi there. We're gonna start our ML lecture number 4. Today we're gonna be talking about optimization and gradient descent, or actually our ML lecturer, Siobhan, will be talking about that. I just wanna plug a few things before we start. So we're going to have a cookie and craft social this Thursday at 5 p.m. It's actually going to be in this very room. So please make sure you show up. That would be really nice, and you guys can have some free food, of course. We also, unfortunately, had to cancel one of our HyperGator tours. So we're going to post more information about that soon. So if you guys were here yesterday, you guys signed up for HyperGator tours, just make sure you check our Instagram for updates on what's going to be happening with that. But yeah, I'm going to leave it to Siobhan to take it away, but thank you very much.
Yeah. Hi, everyone. Today's lecture will be on optimization and gradient descent. So last week's lecture was on logistic regression, and now we're going to build upon that by going into optimization. So this is just some administrative information and how we really want to structure this course and what our objectives are. So we have a number of resources just to get you better acquainted with the content we have here. So a few of those resources include the slides to the previous lectures, which you can find on our link tree on Instagram and our Discord as well. And then we also have our YouTube streams. And then our main goal with these lectures is try to simplify it as much as possible and to really approach it from a beginner's perspective. So that's what we're trying to do here. And if you guys ever have any questions, you can raise your hand anytime. It's totally fine. All right. So how do ML models learn? Because at the end of the day, what a machine learning model is doing is it's predicting things. And what we want it to do is we want it to predict things closer to the actual value. So we want it to be better at guessing things based on existing data. So when we talk about machine learning, we mean that we constantly want to iterate on our predictions. So whether it's logistic regression or a deep neural network or something even like ChatGPT, an LLM, a large language model, at the very core, they all share one idea, and that idea is optimization. We're trying to optimize it to be as efficient as possible. So the continuous process of optimization or improving is the main purpose of machine learning. And the most common way to do that is through a concept called gradient descent. So what gradient descent is, from the most basic perspective, is you can think of it as rolling a ball down a hill and reaching the lowest point. So the lowest point in this case is your most efficient point, and that's our objective at the end of the day with gradient descent. So let me ask a few questions. What exactly does it mean for a model to learn? Anyone can raise their hands. All right, another question. Is gradient descent the only way model learns? So no, gradient descent isn't the only way a model learns. There's other techniques as well, such as Newton's method or genetic algorithms. Did you raise your hands? No. Okay. Yeah, but for the purpose of this course, we'll be focusing on gradient descent. So these are a few of our lecture goals for this lecture. First of all, we want to define what optimization is. We want to review logistic regression, which is our last lecture. We then want to move on to understanding cost functions and convexity, then move on to gradient and descent, and then compare batch, stochastic, and mini batches. And finally, see how tuning our parameters affects learning and whether we're actually improving our model or not. And the reason gradients and optimization are so important to understand in the first place is because every machine learning model, from linear regression to deep learning, relies on these mechanics. So these are foundational concepts in machine learning. All right, so why does optimization matter? Well, when we build a machine learning model, we want the best parameters possible. So when I say parameters, I mean the weight and the biases we have. So these allow us to make our predictions as efficient as possible and closer to the truth. But at the end of the day, we can't just guess random parameters. We actually need to test for parameters and see which one is the most effective. So how we do this is with a cost function. So what a cost function is it tells you how wrong your model is. So you're evaluating a certain percentage as to how wrong it is. You're not really saying whether it's wrong or it's right. You're getting a percentage and a metric for that. And that's more helpful when you want to iterate on your model. And everything in machine learning, from linear regression to logistic regression to deep networks, comes down to solving this one line, which is the optimization formula. So a few common questions are, what is J theta? So J theta in this case is the cost function. So it just helps to remember that that denotes the cost function that we have. And why do we minimize the cost function instead of maximizing something else? Well, because we know that the cost function is a measure of error. It tells us how wrong it is. So by minimizing the cost function, you get as accurate as possible because you're improving your accuracy. Does anyone have any questions? Okay. All right, so this is a quick refresher on last week's lecture, which was on logistic regression. So as we know, logistic regression doesn't really give you a yes or no output. It more so outputs a probability that something is more likely to happen or not more likely to happen. So your first step to calculating logistic regression is to find your z-value, which is the linear combination of inputs. So if you recall back to our last lecture, we talked about y hat equals wx plus b, where w is your weight and b is your bias. So once you get your z-value, you can pass it through a special function referred to as a sigmoid function. So this is the sigmoid function right here. So why do we use the sigmoid function? Well, when you have probabilities, sometimes, like what if I said like I had a 200% chance of passing an exam? Well, clearly that's not possible because at most you can have a 100% chance. So what a sigmoid function does is whatever input you pass it, it gives you an output between 0 and 1. Because if your output is between 0 and 1, you can actually make sense of that output. For example, if it gives you 0.7, that means that you have a 70% chance of passing the exam. So it just helps to evaluate it that way, rather than those values being bounded above 1 or below 1. So the easiest way to think of a sigmoid function is you're squishing whatever values you pass it in between 0 and 1. And as you see in the graph, your y value goes from 0 to 1, and at the middle you have 0.5. So we call this 0.5 your decision boundary. And quick question, why is it called logistic regression? Can anyone answer? Okay, so logistic regression is called logistic regression because it's using logs and it's mapping linear outputs to probabilities. So why can't we just use linear regression as opposed to logistic regression for classification? Because for linear regression, your outputs can be above 1 and below 0, and we don't want that. We want our values to be bounded, which is why we use logistic regression. All right, let's try this. All right, so let's talk about sigmoid intuition. How do you want to think about a sigmoid? Well, for whatever negative z-values, so as we said, we calculate the z-value using y hat equals wx plus b. If your z-value is very small, what the sigmoid function does is it translates it close to the value 0. On the other hand, if your z-value is extremely large, your sigmoid function gives you a value of 1. And if it's something in between, it'll usually go to around 0.5, which again we call the decision boundary. So this is the function for the derivative of the sigmoid. And what you want to note is that if your value is at 0.5, that's your steepest value, because if you look at the graph, your value is steepest at around 0.5, while it flattens around 0 and it flattens around 1 as well. So why does learning happen fastest near the value 0.5? Well, that's because just what we said. So the slope is the biggest or the largest at 0.5, meaning there's more going on at that area. And why does the sigmoid flatten near 0 and 1? Again, because we want bounded values. And it's important to note that the output for sigmoid will never actually reach 1 and it'll never actually reach 0. So it's only approaching those values. All right, let's talk about cost function, also known as cross entropy. So now that we know that our model can predict probabilities, so probabilities between 0 and 1, we need to have a way of measuring whether these probabilities are good or not. So our way of evaluating this is called cross entropy loss, also called log loss. So what you're doing with log loss is for each example, you're comparing the predicted probability to the true probability of something happening. And that's how you measure whether your predicted probability is close to the truth or not. So for example, if a model predicts the value 0.99 for a true 1 value, so when I say a true 1 value, that means that in logistic regression you get that highest value. So if you predict it at 0.99 for that, that's a good output, because that means that your prediction was almost perfect. On the other hand, if it predicts 0.99 for a value of 0, well, we don't want that, because 0 means that our prediction isn't right, and 0.99 means that we're very confident at predicting that error. And we don't want confident errors. We want to eliminate the confidence of our errors. So when I say confidence of our errors, that means that the machine model is saying that it's right at a high confidence, even though it isn't actually right. So we want to eliminate that. And a quick question is, why do we use cross entropy instead of mean squared error? And the reason we do so is because cross entropy punishes those confident errors, unlike mean squared error, which doesn't do that. Okay. Now let's talk about convexity. So what is convexity? Well, if you imagine the loss function as a landscape, some shapes are full of bumps and ridges. So that means that our data isn't necessarily uniform. But for other models, our data is uniform. So what a convex function is that you can think of it as a nice bowl shape, as you see in the graph over there. And from a mathematical perspective, what this means is that if you draw any line between 2 points on the curve, it lies entirely above the curve. And why does this matter in the first place? Because this matters because it guarantees that whatever value you get, we start on the surface, and if you keep on going downhill, you get the most optimal value. Again, this is referring to that concept of gradient descent we were talking about. The more you go down, the more you reach the lowest point. That point is your most optimal value. So this is just a 3D representation for that in the graph. And certain models like deep neural networks aren't convex because their data is just so ununiform, and that's why training them is harder. But for the purpose of this lecture, we're assuming that our data is uniform. And this is a function that guarantees stable training. So now, coming back to the concept of gradient descent, what is a gradient in the first place? So what a gradient is, again, if you imagine your loss function as a landscape, the gradient tells you which direction is uphill. So you're looking at it from the perspective of the lowest point in the gradient, and it's telling you the direction. And you can tweak this parameter depending on whether you want your loss to increase or decrease. So we know that the gradient descent, or the gradient points in the direction of the steepest ascent, so when it's going up. Well, if you wanted to minimize cost, you would do the exact opposite. You would find the direction of it going downhill. And so the bigger the gradient you have, the steeper the slope. And ideally, we don't want our slope to be as steep because we want to reach that lowest value. So a few common questions about gradients are, what is the difference between a gradient and a derivative? So a derivative is a single variable, whereas a gradient is the collection of all the partial derivatives for multiple parameters. So by multiple parameters, I mean that when you change your weight and bias to test for different values, those are your parameters in this case. And why does the gradient point uphill rather than downhill? Because it's showing you the maximum increase in the cost. If you wanted to go downhill, as we mentioned before, you would go the exact opposite direction. Now let's talk about gradients in logistic regression specifically. So how do you compute the gradient for logistic regression? Well, you know that the derivative of our cost function with respect to each weight has a simple form. So we have that function right here. And what does this function actually mean? Well, it means that each term, as you see, y hat minus y, and we have the summation for that. So each term, referring to y hat minus y, is the prediction error. So it tells us how wrong our error is. And if the prediction, or if the model's output is too high, that means that the difference is positive. And that means we want to reduce the weight because our error is too high. On the other hand, if your difference is negative and if you predict too low of a value, you want to increase your weight because it means that your prediction is too low. And we use the summation in this case because we want to average across all the values just to keep our updates stable. So a few common questions for this is, where does the formula come from? And the formula is derived by taking the partial derivative of cross entropy loss with respect to each weight. And the weight is referring to the weight in y hat equals wx plus b. So now let's move on to the gradient descent algorithm. So how do you compute the gradient descent? Well, there's a few steps we want to start with. First of all, you want to figure out what your weight is and what your bias is. Because once you have your weight and bias, you can predict your y hat, as seen in step 1. After you predict your y hat, you want to compute the loss. And the loss is referred to as j. And now once you get j, you calculate the gradient of j with respect to each parameter in the model. And then finally, you update the parameters to become more efficient after each iteration. And we have the function for the updating model right here. So what this updating model is doing is it's tweaking the weight and bias slightly every time and assessing whether that's actually improving the model or whether it's not really helping at the end of the day. So a common question asked is, why do we subtract the gradient instead of add it? Well, we subtract the gradient because the gradient points in the direction of increasing cost, and we want to minimize cost. And how do we know when to stop updating? Well, when the cost stops decreasing, that's our cue for us to stop updating the model and just leave it as it is, because at that point, it's at its most efficient form. Let's move on to learning rate alpha. So that symbol A is referred to as alpha. And what alpha really is, it's essentially deciding how big of a step you should move towards the gradient to become as efficient as possible. And there's a few catches with alpha. If your alpha value is too large, that means you're taking too big of a step, and you don't want to take too big of a step because that means you're overshooting your values. You're not looking at each value, and your prediction isn't as accurate as it could be. On the other hand, if your alpha value is too low, that means that you're progressing too slowly, and it might take extremely long for your model to compute. So this is why we want to take a balance in between a too high value and a too low value for our alpha. Oftentimes we start with a value like 0.01 or 0.001, and then we adjust it based on what our model is outputting. So a common question about the learning rate alpha is, how do we pick the right learning rate in the first place? So we predict alpha, the value for alpha, by experimenting, as mentioned before. We start with a common value such as 0.01 or 0.001, and evaluate each iteration to see if our loss is too slow or too unstable. And can alpha change during the training of your model? So yes, your alpha value can change, and we use what we call a learning rate schedule that decreases alpha over time. And there's also optimizers that do this without manual input, such as Adam's optimizer. But that's more technical than what this course is about. Right, let's move on to feature scaling. So we talked about gradient descent and how to compute gradients. But there's one step we want to ensure beforehand, which is called feature scaling. So what is feature scaling? Well, the best way to picture it is imagine you're trying to descend a mountain where one side of the mountain is stretched 10 times as long as the other side. And so that journey along the long side is zigzagging. So it's not really a straight journey, you're more so going on an uneven path. But the most ideal path we want is a straight path. So in the context of a machine learning model, this happens when your data sets have different magnitudes. Let's say one of my data sets were age ranges between 0 and 100. So if I was like 56, that would fall in between that range. But another data set had a different magnitude. Let's say income ranges between 0 and 100,000. So those ranges are extremely different. On one hand, we have 0 to 100, and on another hand, we have 0 to 100,000. So how we standardize this is by using the standardization formula, which is a part of feature scaling. And this is the formula we use to standardize it. So this is a fairly simple formula. It's your x value minus your mean over your standard deviation. And that just makes it so that the ranges are uniform for every data set that we have. So a common question we have about feature scaling is why does the unscaled data cause zigzagging in the first place? So the reason this happens is because when you have data sets with large ranges, those tend to dominate the gradient rather than those with smaller ranges. And we don't want one data set to dominate the entire set of data. And another question is scaling always necessary in this case? And for most instances, scaling is necessary just because in most circumstances, you will never have uniform data. You'll have multiple data sets with different ranges, and you want to account for that. Now let's talk about a few practical issues pertaining to optimization and gradient descent. So even though the concept of gradient descent is fairly simple, there's a few challenges that come with it. One of the challenges is bad initialization. So if all of your weights and biases start at 0, for example, your gradients won't really have any meaning, even if you do get a value. The second issue is feature scaling. When you have data sets that have ranges that are extremely high and dominate the entire data set, we don't want that. So those are things we want to account for. Another issue is the learning rate A. If you have a high alpha value, your data set diverges, and we don't want that. And finally, another issue is overfitting. So overfitting happens when your model is, at the end of the day, memorizing data rather than predicting based on past data. So we don't want it to memorize data because at that point, there's no reason for the model in the first place. It's just regurgitating past output. So a common question is, why does bad initialization matter? Because if all the weights start at 0, the gradients can cancel themselves out, and this can break the symmetry of the model. And another question is, how does regularization fight overfitting? So how does it prevent that issue of the model memorizing data instead of actually learning from data? So how it does this is it assigns a small penalty for the large weights while keeping the model simpler and preventing it from memorizing data. Right, now let's move on to monitoring convergence. So now we know how the model trains and how it outputs predictions. But we want to know whether those predictions are actually improving or whether it's just stagnant. So how we do that is we use the loss curve. So what the loss curve is it's a plot of the cost j versus the training iteration. So if you look at the graph, the training starts really high and then gradually slopes down and it flattens near the minimum. But if your curve oscillates wildly and it doesn't really flatten like that, that means that your learning rate is too large. So your alpha value is too high. And again, as mentioned before, we don't want our alpha value to be too high. We want it to have some sort of balance. You can also track the validation loss, as you see in the graph with the red line. So what validation loss is if the training loss keeps on dropping, but the validation loss rises, that means you're overfitting, which means you're memorizing data. And a common technique to prevent these issues is to use early stop. So if the validation loss hasn't improved for several iterations of your model, what you do is you stop the training and you actually examine the actual components of your model to see if there's something wrong with that in particular. So a common question we have is, what should a healthy loss curve look like? Well, a healthy loss curve should look like the training model specified here, where it starts at a high point and gradually goes down until it flattens. So that's our ideal curve in this case. Another question is, why does the loss sometimes spike early on? And the reason for this is because sometimes we start with random parameters, and this makes bad guesses because we don't want to start with random parameters. We want our parameters to be efficient and actually thought out for the purpose of our specific model. And another question is, what if training loss decreases but validation loss increases? So again, that means that you're overfitting. The model is memorizing trained data and it's losing that generalization. All right, and here's a summary of what we've covered so far. So we've covered optimization, which is finding the parameters for minimizing cost. We know that gradient is that slope for the cost. Descent is moving opposite to the slope. So you're moving higher and higher along the graph. We know that learning rate A, which stands for alpha, controls the speed of your model. And then we talked about how we want to scale our model through feature scaling. And finally, we want to monitor cost curves to see if our model is actually improving as opposed to it failing to improve. All right, thank you for our lecture today. If you missed the sign-in form at the beginning, you can sign in right now. And does anyone have any questions? Anyone? Yeah.
So for the validation curve,
Mm-hmm.
can you tell us how the optimal validation curve should look like? Because here you said when it went up, it means it's overfitting, right?
Yeah.
Yeah. So how it should look?
Yeah. So your ideal curve should look like that blue line over there. So it should start at a high value and then it should go down and gradually flatten out.
Okay.
Does
So
that?
it means it's not overfitting or underfitting?
Yeah. Exactly.
Okay.
Does that answer your question?
Yeah,
Okay.
Thank you so much.
Does anyone else have any questions? All right. Thank you guys. Wait, you want to say? You can say. Oh.
How'd you feel about it? Different numbers. Yeah. How'd you feel? Was it? Yeah, no, it was good. I mean, yeah, it was up to it. That's okay. Sometimes it happens.
I didn't know like what to say a lot. They wouldn't say what to say.
Yeah, it's not about anything.
Oh,
I know anything about like building apps and
Oh, basically just like an app generator and also
I'm assuming this is machine learning, so like
I know.
Yes. All these components and the last thing I was just saying something I just said. But I'm just curious, like, you know, I'm assuming ChatGPT is able to do everything you said.
But if you wanted to do it on your own,
Yeah, it's cool as collected.
you would just start with an idea and you just like break that into
And then ChatGPT tells you step by step, right?
Yeah, and then you just don't want to
This guy's doing our mentor.
you want to like try to
So when the error
I came first, like, the second lecture, and then I kind of just, like, didn't see the intermittent, like, so I just missed it, yeah.
Were you there for this? So that was when you were
I just like show you
I
like
think so.
What did you think about that one? That was I was doing that.
Yeah, you were the I thought it was good. I liked the
ChatGPT like giving you directions basically.
I liked how you kind of related everything to you were kind of focusing on like every concept you talk about relating it to like what was it? It was like property cost or house cost or something like that. I thought that was useful because a lot of times it seems kind of abstract and you're just like this and this and this. So I think like yeah. So whenever if you can like since I'm like a noob, if you can like relate it to some like concrete concept, I feel like that helps a lot.
Do you think it's the same too? Alright, how do you think about this today's lecture?
All this was just to make like, do you know what expo
I feel like all the topics made sense in isolation. Oh yeah. I wanted to see how they fit
It's like when I click on it
together.
and then actually like.
Yeah, I agree.
there's like no Wi-Fi.
Like looking at
When
a
it
bigger
loads,
picture of
like,
everything.
all of this was just in
That
like
doesn't make
the
sense.
loading screen and saying like, okay.
I get that.
So like that's because I think it's by doing it on this app. So every time I update it,
Also,
You come out to the ML lectures and then also I think we're gonna have events. So come out to
Yeah, I've been trying to come to these every week, so I'll be here.
I'll text the group chat too. We got you now.
I know.
You do like roller
Oh, you guys climb? I'm like, I so like climbing. My girlfriend is, and her family is all super into it. Like, my girlfriend's sister works
share
at
the
the
information. If you
she like sets rocks.
Wait, actually?
So like,
Yeah, Ella,
I'm trying
you
to do
guys
that,
know
but like,
Ella?
I'm not maybe you guys were able
She
to
like
help
she does
out
some of the
in
setting
way
for the
if I
boulders
get
and
one of
stuff, so
those
she
boards
climbs a lot.
from the
So.
He's a big climber.
Yeah,
I just got
I
one.
suck. I'm not good, but I probably hit like
Like, as part of,
one
like,
V or
GatorAI or
four
something.
before, like maybe.
Dude, I don't think I've ever hit him before actually.
Well, it's all like I just don't do it
If I have
consistently.
this
I just like
document signed, like,
my girlfriend's
I think
family's
it's-
so into it, so whenever they're hanging out,
Like, I don't
just
wanna
get
tell
us.
you, bro.
I
So
just
I'm
got
like,
a membership actually. Like, actually, yeah, literally.
I want to get one, but I'm like,
I've never really
they're so expensive.
I know.
It's
Yeah.
so expensive.
You guys just like wait if you're trying to.
I did take out a bunch of buy this.
Wait,
$80.
don't they have to?
No, I'm not actually like.
have access to your
I just
code?
don't want to
Sure,
spend
yeah,
money
but
on
like
it.
I'm taking the idea itself.
Huh?
What are you gonna do?
I would be hard to
Probably
replicate
going
like
30
the
months.
someone
Yeah,
else,
literally in
like,
like 2 months.
in case
one of my
someone
PhD
needs to
applications
do
are
it.
like.
You could always
done.
add that to it, but I don't know how.
Yeah,
to-
that's farther along than once I actually get it built. Right now,
Yeah, I'll
it's
see you
like
guys
not
around.
to show for it, it's just a bunch of code, the back,
Yeah.
behind it.
But also, I feel like every idea is already been done. You're just adding your own stuff.
It might be true, I don't know, maybe I have an original idea, maybe I don't, but
Yeah.
is there anything that like you guys know, or like, do you think like there's anything about like using ChatGPT to it's just like saying add code here, I think it, I'm doing it on my phone, it's add code.
Well, I would like suggest like you actually learn it. So like
anywhere else?
I do can actually explain like song.
Like learn how to code.
I'm really happy you like that.
Yeah. So there's also resources like Stack
I took an exam.
Overflow.
You can have your like resume on a PDF. Because everyone
So you might want to like look at those first and like if
You're
you still
saying,
don't
I
get
could
it.
like parse it out.
Oh yeah,
Sounds
like
like
it's
understand
annoying.
it.
Like
You're saying
close
that
your laptop.
No,
I just
Stack
downloaded
Overflow
PDF to
works
simplify
best.
it just
So
to be,
if you like type what like your
On the floor?
errors, it'll just like give you like other
Oh,
people's
right,
answers
right,
to your specific error.
I will not be. I
Chances
will not
are
be
about
on
someone
the
else.
floor.
That's only if like things are desperate.
Like you think when they made an app or something,
Yeah.
like this, these the same problem.
Because most errors are pretty common.
Oh yeah.
Do you know how to do the actual AI is doing?
I haven't done it before.
I talked to ChatGPT enough, they'll tell me.
That's fine though.
I've been on the
So
phone for, like,
integrating
the
actual
first
AI is
couple
actually
hours.
pretty simple. Because like companies like
Yeah.
working in AI generally, they have their own like integrations. If you just look at like how to cook up like those AIs to your
Like,
model.
let's say you're trying to, you heard of SOAR.
Maybe that would be
Yes.
easier.
Crazy, right? So like, is there a way that we can like implement that, you think?
I feel like everyone's
I do like
before, like,
You can make
I
your
feel
own
like if I
avatar.
wasn't one,
Yeah.
it would be like sacrilegious.
I think you could use Sora, but Sora is big. So you would have to like get the
And
track.
right now you're doing like the code for it, right?
Yeah.
Yeah, well that, okay, so that's that, but like, that's like more advanced if I was trying to make a real avatar, I know that just became a thing too.
Yeah, but if you wanted to look up like ChatGPT, that's
Not
pretty
fourth or
easy.
fifth, because I want to be able to speak
API
without
keys.
getting shot.
Like, what's the API?
So an API is a way to connect the AI to your code. So if you just search up like OpenAI APIs, there should be some free ones, and then you can just search up like how to hook it up to your code specifically.
Can I ask you?
Yes.
Sounds good, test me.
That's like farther along once let's say get the sign-in screen, get the login page, and then like whatever I'm building. But do you think if I could just follow ChatGPT now, you could like keep following it, it'll like build it for me? And then,
Yeah.
okay.
Well, like, do you want to like learn it, or do you want to just like build it?
Like I want to build it. I don't really care. about what the code means, honestly. I'm just trying to
Yeah, then he'll do it.
Yeah.
Yeah, he'll do
So,
it.
I mean, like, what, you think it's necessary? Like, let's say I'm like making an app, or not, like, I can explain it, like, there's no reason, but there's no reason to explain. If it's already built, then, you know what I mean? Like,
Yeah,
it's
that's
not-
fine. I'm just trying to figure it out.
Oh, yeah, I'm not a concept major.
Okay, yeah, then that's
I
fine.
was interested in looking at one program that I realized like ChatGPT kind of does it for you, and it definitely is useful to like.
Dude, come on, bro.
And
It's
it
literally
makes
right
sense. I
before
understand the
the
reason for that.
Yeah.
But I'm just thinking that okay, ChatGPT already exists.
Yeah.
May as well just take advantage
Dude, I
of it
literally
and try
cannot
to
get a
do
job,
what
bro.
I can, you know?
Cut me
Yeah,
some
it'll walk
slack.
you through
Literally
like
cut me some
stuff.
slack, bro.
Okay, that's what I was basically I was just asking like what if anything that you guys can do to
Dude, they
help,
have,
or
like, you hear
if
them
I'm coming like
100,000
maybe next semester with a project or anything that like actually.
Because I believe we have like
Yeah, it's
project
literally like,
lead
I don't
application.
know.
Well, I'm not saying I want to work. I don't want to work in it.
I don't have an alternate.
And act like a pitch project and you get the sign off and then you build it further.
Yeah, so you would do a project.
So do you like honestly? Do you think any of these kids that can actually like help their career get farther along with their knowledge of code, or do you think with
If that part of the
AI?
project they would help. Because that's part of what they apply.
Okay, no, I understand that. I'm saying, do you think what's more productive, like using ChatGPT to just build it, or other comp science students that?
Well, you can do both. Like, if you have more
True.
hands on
That's
it.
true. That's true. But you think this is the best way to come for that, right?
It's just
Yeah.
overrun by comp sci.
That
Everything there
kinda
is comp
answers
sci
my
major.
question.
Yeah.
Maybe
Alright,
the ones
well,
are like the clubs ones. Like
That makes sense. I mean, I guess I'll just keep
Yeah.
going along, because I can't really do anything until next semester.
Well,
It's
it's
over.
not
I'm still gonna build as much as I can and use ChatGPT and keep adding code and adding code and see as long as we come up and I would share that idea with you if I had like these papers, because I think it's like a great idea, like if I can make this into an app,
Chef,
make
no,
it
Chef
profitable.
conference is way better. Chef
I just wanted to
conference
ask you,
is
because I know
all
you know
the
you're talking about.
Space is
Yeah,
garbage.
okay,
Space
yeah.
is garbage.
But it's
Do you
all
think I
in
just
the
keep relying on ChatGPT?
Shall we do this?
Yeah, and then maybe like when the spring semester begins, then
Yeah,
you can apply for
both of
project.
them.
And then I
have
can
other
share.
people as well.
Okay, and then I can try to get
I think
people help.
I got an
Yeah.
interview.
It's all-
I think there was a kid, I forgot his name, he was a
Exelon
senior, and he was trying to make his own app about like
Chef.
a,
I got an interview.
supposed to like,
Exelon and
almost
another
like
one.
investment banking, like mimic like
Alright,
financial
October
modeling or something.
It's really soon.
He was here like 2 weeks ago, I don't know.
Sure,
So,
but they're just
what's your name?
facts, like,
Shouldn't.
Ethan.
What's your name?
But you could
Yeah,
go
nice
to
to
the
meet you.
chef.
I see. Are you like
I was all
Okay.
I was just like,
like
have this idea.
I feel like if you're
Make some
really
money off it if I could actually.
desperate,
It
like
should be
junior
cool, but
go,
just-
but
I know you guys
sophomore
are
year,
professional, close enough to
I think
professional
so.
and get stuff, so that'd be.
Yeah.
I think Chef is.
Does that answer your question?
I don't know. I don't know if my friend.
Honestly,
my
like,
friend,
I'm just
he's
kinda
not Hispanic.
I wanted to hear like your.
I went, I
advice.
got my.
I was just.
Like building your own.
I think you
Yeah,
got an
and like,
interview
well, I
from
guess,
Apple.
and then the answer
Yeah,
like,
no
was
one-
after,
no one-
back in
no
the
one I
spring
heard
for like
from
more help with that,
them,
but like,
like,
any of these
on
lectures
that
really,
travel
they
guide.
wouldn't help me, because they're all
I
trying
got my
to
video.
Because they're more
I
like
don't think it's
theoretical,
gonna show.
so like
You
what
sure?
you're doing
I
is
think it
more
might have
practical.
been.
You're
I
actually
think you might have gotten it from Chef.
Okay.
Because my friend
Like-
also like 3
You're
months
doing
later.
Mine's in January.
I honestly
How
had
did
no
you
idea
know
what we
it
were
was
talking about
Chef?
that whole time.
He said
Like, so,
he
like,
never
what-
even applied
Like,
to the.
what is that? Like, I know, I
He got
know
emailed by the
I took
recruiter and the
calculus,
recruiter was like, hey, I saw your
like,
resume in our database
Yeah,
and I
like,
thought you were a
I
good fit
took,
for this
like,
position. Like, how do you
to
even,
gain the AI.
like, there's no way.
Okay.
So like, I took
I
like
applied
basic
to
classes, I understand the
Yeah,
basics
that's
of
why he
AI, I
thinks,
know
like,
what machine
somebody
learning is,
forwarded
like,
his
it has
resume.
functions, and like,
I
you,
don't
for
think I got it.
TGA, that's funny, I
I had a
never
fun
knew,
time,
like,
dude.
how
I had a fun
high
time.
one of my, like,
You
how
didn't even
many
go to
curves
the
were
Halloween
working.
Horror Nights.
Yeah.
Yeah, I didn't.
Oh, lame as
So
that.
like,
This dude got like the Microsoft
So
Explorer.
if you wanted to learn,
About, like,
how
how
you
you like experience.
Is that what you're
Did they cancel?
what do you think is necessary to learn?
Well,
I
you're
mean,
not
that's
do you think
that stuff is different.
So
That's
the-
like
for
for
the
the purpose of
I'm saying the
That stuff is genuinely
pure
like-
like practical,
Yeah, they got-
like,
yeah,
just
yeah.
building this
Yeah.
app is like,
Really?
I'm not necessarily learning.
Got rid of
No,
it.
you don't.
Do you have a new one? Too bad for it?
What do you guys have major?
Oh, yeah.
Solid
Okay.
on the one
What
thing.
are you trying to do?
Yeah.
Yeah, I think it's just
Like
because
job- like job
they were
ones.
choosing,
Oh,
they didn't know how to
like,
choose
like,
people because everyone's
sweet.
freshmen, like barely anybody has experience.
No, it's
Like if you work for like Apple or Google,
Yeah,
like,
it's
Yeah,
waste
yeah,
money.
that's the goal.
I mean,
It's like
you
working
can
for like
kind
most
of
people.
tell.
Hey, I'm
major.
with it.
Like,
Yeah,
that's
you
cool,
got-
yeah.
you got
So it's like,
whatever.
I can't imagine what they're doing now there.
Yeah.
Like,
Paul was
I
a
might
go-to
know
everything
first
has to do
year,
with machine
probably.
learning,
You probably had a
right?
crack
Everything
resume
you're
from the
building.
start.
No, it doesn't matter. Cool.
Like all the like most
This is
exciting
like,
things.
this is
Yeah.
interview question.
Yeah, like the more futuristic looking
Yeah.
stuff.
Yeah.
I'm surprised
Do you
you
think I
had
just
an interview
rely on
question last
ChatGPT
year.
to keep building as far as I can, and
Yeah.
then, but knowing it wouldn't really take me any further.
Oh,
you're saying.
Some like string bullshit.
Not for this
I might-
app because
I might
like,
have
it wouldn't
volunteered
really-
at the Google event that they're having.
But it would also be the
This
most
app
helpful
is-
for college students to help me with this.
Oh, I have no
Exactly.
idea. I went to a
Okay.
freshman year,
Okay.
and now I'm at
Sounds good.
Google, but like.
Alright, well, I'm just gonna keep trying to go as far as I can, but I guess there's no point in me coming to the lecture, right?
I mean, if you're doing the app.
Just play, like, go, just like, fill out whatever
Thank you.
form,
That's right.
QR code they have.
You
I appreciate
kind
it.
of just have to put yourself.
That's the only thing that I feel it works.
Thank you, nice to meet you.
I don't think it will do
I'll be
anything
back in
to
the
go there
spring.
and, like,
Yeah, sure.
Blaze
Are
talk to
you-
recruiters, just go and just like scan a QR code, say you
I'm a second.
sent it, send my
You're
value.
software too.
I'm lucky fucked. I'm
Yeah,
not
so
gonna lie for jobs.
come back in the spring, hopefully.
Yeah, I don't know why
So I
you
just
like that.
apply, how does that work? So if you just like,
Look at our Instagram, where you can have a post.
Yeah, you're not
okay,
fucked.
so I just wanna apply to be a,
Project lead.
but is that possible, even though I know nothing about reconcile? Like, is that-
No, I don't.
Like, you guys would still like let me
Yeah,
do a project.
It's so much
Okay,
it's so
awesome.
much work.
Okay,
It's
sounds
so much
good.
money
Thank you so much.
to apply. Like I'm
Hi,
gonna be
nice to
spending
meet
like
you.
$2,000,
Craig.
bro, doing my application.
Nice to meet you. Great lecture.
So much time.
Yeah, I don't even wanna do my
Was
master's, but I'm
curious
like
how
kinda
you
forced to now.
figured out like what you wanted
Because
to
of Google,
specialize
I have to do a
in
master's
AI.
degree.
Like,
Well, where are you
how
gonna do your
learned it.
masters?
I don't know.
Yeah, so
Wherever.
I was reading
Takes you?
on it,
Yeah.
so, like, some
I think you'll
personal
get into that.
projects
You get at
on
least
it.
get into like Brown
Or
or
Georgia
now.
Tech,
So I was
Georgia
just like,
Tech.
playing around
All
with
of them,
these
right?
models, like, open
Yeah.
source, and
Georgia
then-
Tech.
But I'd rather do in person.
Like, what it
Really?
was, it was, like, really
Yeah, if I'm
exciting
like,
at that time.
I'm not gonna just stay at home for
Can
all
you
day.
apply to both of them at the same time?
I don't know.
Mhm.
I have a-
cheaper though?
Is that?
Yeah,
Yeah,
it's so
yeah.
dirt cheap.
And
I'm sure
what,
it's dirt cheap, and
um,
also the acceptance
but I
rate
also
is
So
wanna
it
high.
sounds like you specialize in
Yeah.
like.
I really wanna graduate in a year,
LLM.
'cause that's what I told them when I
Yeah,
graduated.
And like, just like neural networks.
And also, I just wanna start working.
Nice,
'cause, like,
nice.
it's really-
And
I'm
is
not
it like
smart.
kind of
Especially now that I have like a
some of the
real.
open source models and like making
Yeah,
those
like,
improvements? Okay, that's cool. That's cool.
Like, to actually like make those large models, that's a lot.
But like a lot of companies are like iffy on it because like they don't know what's going on with the $100,000 fee. Like, you know, it might be
Yeah,
it
that
might be
does.
appealed, it might be like
How do you
rejected.
kind of like
I heard a
get
lot of big
started
companies
like
are like
learning what you
just
needed to
being like,
know?
nah, it's not. It's like
I think
they-
Amazon
Yeah.
still is, but Amazon sucks to work for. So.
I mean, I'd be fine working with anything for Amazon. I'd be fine working at any company, bro, that pays me.
It's some shit where like a lot of people don't even.
I think once you get those, like, you can start applying.
Yeah, they hate it. It's yeah, but
Okay.
I mean,
And did you
it's,
have, like,
you know, if
Python
you, in your
knowledge
situation, you
before?
gotta
I'm
take it. You
dealing,
gotta
bro.
take
Like,
it.
any job
just
over
very
like
good.
100K, I don't even care, bro. I'll take
And
it
is
literally over. I don't know.
the
depends on
machine
what
learning
PhD
courses, were those like Python heavy?
Yeah,
Like
I
what
get
was
it, I
kind
get
of the?
it.
So machine learning is usually.
You like
Python
Vincent's
heavy.
Okay.
Yeah, because that's something.
Oh my god, dude. I'm not gonna do that, bro.
Gotcha.
Like, eventually, like, you'd be
Okay.
a-
Well,
like, you'd be
yeah,
a
no,
project
just trying to
position.
navigate the
I
AI
don't think
space,
that-
see what
I
I
don't
learn.
think this
That's
is
what I
how it
appreciate
works.
it.
Yeah.
I don't even think that's
Have a
how
good
it
one.
works. I think you
Thanks.
guys need a PhD.
No, but like a lot of the professors also don't have PhDs here.
Oh wait.
Like the programming language classes professor I'm taking.
Good job, bro.
Thank you. Was it a little short
Oh,
though?
you came from industry.
Yeah, but it's.
Yeah.
Same with the database.
You went longer last week, I
Oh
think.
my god.
Yeah, but there wasn't a lot to like talk about like optimization specifically.
Yeah.